Hello everyone, my name is Matthew Roach. I'm a program manager on the Cortana analytics team at Microsoft. Today I'd like to talk to you in this video about the information management capabilities present in Cortana Analytics Suite. Now, when you think about Cortana Analytics Suite, what you often think of are the capabilities for visualization and advanced analytics that are possible through Azure Machine Learning, through our phased vision and speech recognition APIs, and a lot of the business scenarios such as customer churn detection that are built into the suite. But a lot of these capabilities are based on having the right data in the right place at the right time and having the necessary insights to make sense of that data. When you think about Cortana Analytics Suite, if we take a look at this slide, what we actually see is that these capabilities for action and insight towards the right-hand part of the slide are really based on making sure that the data that is being sourced from existing systems and existing locations are available, that they've been processed, that they've been put into the location where the analytics tools can work, and are available for the necessary people, for your data scientists, for your business analysts, for your business users, for your data developers to do their work without needing to hunt for the data, without needing to reshape the data, without needing to do all of that heavy lifting. And this is where the information management capabilities in Cortana Analytics come in. In this presentation, we're going to take a look at Azure Data Catalog and its capabilities for data source discovery. We're going to take a look at Azure Data Factory and its orchestration engine for big data processing in the cloud. And we're going to look at Azure Stream Analytics and its capabilities for real-time data processing using a friendly and familiar SQL-like language. And we're going to look at it in the context of a connected cars or vehicle telemetry demo. Let's take a look at some of the components that are part of this demo just to provide the broader context that we'll be looking at today. First and foremost, I want to stress that we have two different paths of data coming in. Now, this is something that is more and more common in advanced analytics scenarios today, where unlike 5 years ago or 10 years ago, where all processing was batch processing, you'd have a nightly, or if you were really optimistic, hourly load and refresh for your data warehouse and your cubes. Today, it's very common to need a second or a small number of seconds delay for the insights for the data as it's flowing in from sensors, from connected machinery, be they cars or production equipment, manufacturing. Having those insights and analytics on top of them is key to getting more value and using the data that you have available as a real differentiator for your business. So the top part of the diagram describes our hot path or warm path of data coming in. We have a source application that is generating data for the demo, simulating data flowing in from sensors in cars. So it's more and more common to see cars on the road that have internet connectivity, that have sensors about acceleration, deceleration, velocity, location. A lot of this information is flowing in real time, especially if you have one of the newer cars that's out there. And in this scenario, we've got this information being fed into Azure Event Hubs. So Event Hubs provides an open API for taking large volumes of information. In this case, we're just writing JSON data into Event Hubs to have it loaded into the Azure cloud for downstream processing. And in this case, we have Azure Stream Analytics that is sitting and listening to the data that's coming in through the Event Hubs. Stream Analytics is doing two different things with it. The first thing is we're looking at data to identify patterns in driving behavior. So we'll look at least a little bit at how we are looking for aggressive driving as an example. So we've got Stream Analytics that is feeding data into a machine learning algorithm, and at the same time, we've got Stream Analytics that is taking this data, doing aggregation on it, and writing both the aggregated data and possibly the full data set as well into persistent storage for later downstream batch processing. So this information is going into Azure Blob Store, it's going into Azure Data Lake Store, and we're also using for our cold path, or for the batch processing down at the bottom part, we're using Azure Data Factory to do processing, to do partitioning, to do manipulation of this data in batch, working with data at scale, again, to get it into the right place at the right time. And both of these paths are feeding into Power BI dashboards so that users can look at visualizations, so they can work interactively with the data, so they can take advantage of the fact that this data is in the cloud, is available to them, and is discoverable. And that discovery is made possible by Azure Data Catalog, where during the solution development process, the developers who are loading the data into Azure Blob Store, or the business analysts who are driving the process and giving requirements or giving direction to the developers, or perhaps actually the BI developers who need to work with the data, any of these folks can register those data sources into Azure Data Catalog and provide their insights, be they technical insights, be they business insights, be they insights into the data science goals of the data, or how it's being used, I should say. So that information can be captured in Azure Data Catalog so that other stakeholders across the business, whether they're the same people on the same team, different people on other teams, that they can get this, what was previously tribal knowledge, to have it available as part of the centralized data source discovery process. So let's actually dive into the demo and take a look at some of the pieces that bring this together and how you can use them as part of the Cortana Analytics suite. Let's jump out of PowerPoint. We'll come over here into our Azure dashboard, and let me also point out that while this demo is going on, we've got a stream of data that's coming in. We have a car event generator application that's simulating this ongoing real-time stream of data that's coming in from our fleet of connected cars that we're monitoring. Let me zoom in here real quick and just demonstrate what we have going on here. Is a stream of JSON formatted data that's being written to that Event Hub's API. So we've got ongoing data. We've got a couple thousand, I think around 10,000 cars simulated that are feeding data into this system on an ongoing basis. So we've got that here. Now let's take a look. We'll begin by looking at the Azure resources, and we'll start with Azure Stream Analytics, since this is where we're doing our processing on that hot path, where we're working with that data that's coming in from our fleet of cars. So down here in my list of Azure resources, I'm going to choose my Stream Insight job. And here we can see for our job topology, we have 2 inputs and 3 outputs, and then we'll see the query that connects them. So first of all, let me just stress that for inputs, we have both our Event Hub source. This is what is streaming in real time from our car fleet, and we also have a blob source. This is our reference data. This is very, very common where in a hot path scenario where you have this real-time data that's feeding in, most of the time that data is as small and as efficient as possible. You don't want long descriptions being submitted over and over again in every message. So you've got IDs that then need to be dereferenced or looked up against some sort of reference table or master data in order for them to make sense. So we've got these 2 different sources that are coming in, and we have 3 different outputs as well. And let me zoom in here too, and let me just stress this guy. We've got data that is going out to Azure Blob Storage. So for this particular scenario, we're taking this data that's flowing in real time, and we want to have the full data that's being written out to our Blob Store. We also have an Event Hub out destination. So basically we've got this output where we're writing it back out to the Event Hub so that it can be processed further by other Stream Analytics jobs, or in this case by an Azure machine learning algorithm, so we can do real-time analytics on top of it downstream. And we have a SQL database output where we can take this aggregated data and we can write it to a SQL Azure database or Azure SQL DB for later analysis and processing. We've got the flexibility to take the data and put it where we want it to be. It's flowing in. It could be Event Hub, it could be IoT Hub, but essentially we've got this real-time data that's flowing in. We can do with it what we need to based on our scenario. and it's the query that sort of makes the magic here. Since this job is running, the query isn't editable. So what I've done is I've taken the query. We've got 3 different select statements here. So I've taken the query and I have copied it into SQL Server Management Studio. I want to stress that these queries can't actually be executed in Management Studio. We've got it here just for the ease of viewing and the nice color formatting that SSMS provides. So we've got those 3 different select statements where we have standard SQL syntax, so the same sort of syntactical familiarity that you would look for when adopting a new technology or when leveraging your existing skills in a new place. We've got a select statement. The key thing here is we've got our blob source, this reference data, being joined to our Event Hub source, so the real-time data stream that is coming in, and we're dropping this out into that Azure Blob Store output or destination. So we've got one select statement. It's defining a query on top of the data. Notice that there is no aggregation going on here, so we're simply doing a join, dropping it out into that Blob Store. We also have here another select statement, the second one in the list, that is doing a similar join, and it's dropping it out into our Event Hub output. So again, for later downstream processing, we're enriching it through the query, but we're not doing any temporal processing on top of it. But in our final query, the third query that's running as part of this job, this is where the power of Azure Stream Analytics actually shines. So in addition to having our regular select statements as we saw above, we've got a set of aggregate functions that we're performing, but instead of simply grouping by or aggregating by the columns that are in our data sources that you would going against a regular relational store, we actually have in our group by clause this tumbling window function. So Azure Stream Analytics has a series or a set of different windowing functions that allow you to apply different temporal semantics on top of the data as it streams in. You could have a sliding window, you can have a tumbling window, there's a wide variety. I'll let you look up the full set in the documentation, but essentially what we're doing is every 3 seconds, we're aggregating the data based on the business rules that we've defined, and we are writing that data out into our Azure SQL DB. So anyone who needs to get this real-time data, they can simply query the SQL database and do whatever analytics they need on top of it. It also gives us the ability to see this aggregate information over time using any tool that knows how to work with a SQL source. So let's jump back into our Azure portal. Let's close out some of these blades here. And let's take a look next at our Azure Data Factory. So here we have the data factory for our connected cars. I'm going to click on this guy and wait a second for the blade to load. Here, down here in our contents for this factory, I can see that I've got 11 data sets that we're working with. We've got 9 pipelines and 5 linked services, where a linked service is essentially a pointer to some data source that's external to Azure Data Factory. This is where the data is stored that we'll be manipulating. A data set is some tabular representation of data. Could be big data, could be on-prem, could be in the cloud, but we've got data sets that we are using either as inputs or as outputs, and the pipelines are where the work happens, where the magic happens, if you want to think about it that way. So I want to look, first of all, or I guess I want to look at this one specific pipeline, which is our aggressive driving pattern pipeline. So one of the things that we want to do as we're managing a fleet of cars is we want to identify the cars and hopefully from there, the drivers as well, who are driving inappropriately in our fleet. So if you imagine that you're managing a fleet of cars, you've got access to this data, you're very concerned about your insurance rates, the safety of your passengers, things along those lines. So digging into this pipeline, we have one input data set, one output data set, but it is the script that is probably going to be the most interesting thing. So let us look at the definition, and I am going to back up a little bit because I clicked on the wrong thing in my demo. So we're going to close this guy out. In our aggressive driving pattern pipeline, we want to see if we can identify or help identify aggressive drivers in our fleet of cars. If we're responsible for a fleet of cars, odds are we are concerned about things like insurance premiums and passenger safety. So this pipeline is part of our overall data factory that will help us through a Hive script identify the patterns of driving that we want to be aware of. So here in our blade, I'm going to come into this pipeline and scroll down, and I can see that in addition to the inputs and outputs, so the data sets that are consumed and the data sets that are produced, I've got a single activity here. And if I click on this, I can see that it is a Hive script that will both create a table. If it already exists, it will drop it first, and we then have the ability, or it will then instruct the pipeline to perform the logic defined in the script based on the business rules that we have here. So here we are going to look specifically at the gear position, the brake status, and the speed, so we can use these as criteria to help us identify the driving patterns that we know that we want our drivers to avoid. And this can then feed down into downstream processing, perhaps with a machine learning model, where we can do even more work to reduce our costs, keep our insurance down. The technology, of course, is being applied for a reason. Here we have one specific example. And as I scroll further to the left here, we had originally dug down or drilled down into one specific pipeline. I want to come up here and take a look instead at the overall diagram. So this is one of the things, or one of the places where Azure Data Factory shines, is being able to both define and visualize the overall orchestration flow for our end-to-end data processing. So here we can see that of the data sets and of the pipelines, we can see the relationships between them, we can see how the data flows from one to another, and we can see how they interact with other data sources and other processing. So we've got copying, we've got identification, and we've got the data sets that can serve either as a source, as a destination, or as an interim storage and processing location. Now, one of the key things to keep in mind is that each one of these data sets could exist already. It could have purposes outside of this pipeline or outside of this data factory, and it could be valuable to other users across the organization. So when we think about working with data, very often the data that is valuable to us is being produced by another team or another part of the organization, perhaps a different organization entirely. This is where Azure Data Catalog comes in. So I'm going to jump from the Azure portal into the Azure Data Catalog portal, and I'm going to look and see what data sources and what data sets I can find that are related to this vehicle telemetry, to the connected cars that I'm tracking. So Azure Data Catalog will allow me to, on top of my organization's data, to search, to browse, to filter. And the first thing I'm going to do is I'm going to search on the term vehicle, and I'm just going to type it in, and I'm going to click search. Let's actually click that guy, and that will make that appear. So even though I have not used any specific technology, or I haven't used any technological terms, what I can now see is a set of data that matches that simple text search that I have defined. So as I come down in here, I can see that of the data sets that have been registered in Azure Data Catalog, we've got 15 that match the search term vehicle. I can see that I've got some Azure blob stores. So there is an Azure container here. I can see that there's SQL Server as well as analytics. And I see as well that I can further filter based on tags that have been assigned, based on the object type or the source type or the experts that have been identified inside the organization. But what I actually want to do, if I'm trying to find what are the data sources that are related to this end-to-end application, let's say that my next task is to build a machine learning model or to build a Power BI dashboard that works with the data that is being produced by this system, that is being produced by this data factory. And I know, just perhaps based on a hallway conversation, I know that it's stored in Azure Blob Store. I'll choose this guy. When I click on the container, I can see both properties. So notice that we have both the underlying technical name or the object name of the data source, as well as a friendly name that's been provided by another user. I see that someone has both provided a full description, they've identified experts, they've identified tags. Let me click in here and I can explore some of the details. We'll hide the properties for a second so we've got a little bit more screen real estate. So I can see both the details of the container itself as well as the details of the, all right, so, and again, internet connectivity is slowing things down. So I'm going to start with hiding the properties for more real estate. So I'm going to hide the properties here so we can see a little bit more screen real estate, and we can take a look at just the contents of this one particular Azure container. So I've got the containers selected right now, but I can see all of the blobs, either individual folders inside the container or individual files in those folders. The key thing here is the things that are registered should be whatever is a logical data set, be it an individual reference file or very likely a folder full of files. But in addition to the high-level properties, I can also, while my container is selected, come in here and view the documentation that has been provided. So here, another user, a data steward, or perhaps the developer responsible for maintaining the store, has provided the description of the JSON format for what's being stored in here. This will allow me, as a data consumer, both to understand and better utilize this. If you think about what you would usually do, it's really a matter of trying to figure out who to ask, the right questions to ask, where do I look for the documentation? A lot of that legwork, that very manual process of discovering and understanding data, is now automated and simplified using Azure Data Catalog. And perhaps the most important or valuable information that's in here is that I can see the connection information for where the data actually lives. And let's assume that I do not yet have access to work with the data itself. I don't yet have permissions to connect to this data source. Here, right inside the catalog, I can see the process to go through to request access and to get access for whomever is in charge of that. So let's jump from the demo information. Let's actually jump back into our slideshow. Let's take a look at the services and just sort of wrap things up or provide a capstone for what we've looked at in the demo. First of all, we saw Azure Stream Analytics. So Stream Analytics gives us the ability to work with real-time data using a familiar SQL-like language. We can define these standing queries on top of the data, data coming in through either Event Hub or IoT Hub, and we can write it out to SQL, to Blob Store, or to Power BI or other locations. We've got Azure Data Factory that gives us the ability to compose and orchestrate data. So whereas Azure Stream Analytics is focused on that hot path of data, working with the data in real time as it flows in, Azure Data Factory is more batch-oriented, that cold path of data, but really with the power of working with data in bulk. And again, we've got the ability to go from a variety of data sources to a variety of destinations, including targeting Power BI and Azure Machine Learning to work with the data that is being produced. And to pull all of this together, we have the ability to use Azure Data Catalog for data source discovery. The key thing with the catalog is that no matter what tool you're using to process data, whether it is Stream Analytics or Data Factory or a data visualization or data analytics tool, you can't work with the data unless you can find it, and you don't know if it's the right data until you examine it and understand it. The catalog uses a crowdsourcing model where any user can register data sources into the catalog, and any user by default can annotate the information or annotate the data sources that are in the catalog, so that the things that have traditionally been tribal knowledge inside an organization can now be captured and presented alongside that technical metadata, so that users have a single place to look to discover the data sources, to understand what they discover, and then work with it in their tool of choice, using the information that's in the catalog to help them understand what is the right data for their job at hand. And of course, through that crowdsourcing model for annotations, any user can provide their own perspective and their own knowledge into the catalog to provide additional value downstream. So Cortana Analytics Suite is much more than just information management. There's still all of the capabilities for data visualization, for advanced analytics, for machine learning, but the information management parts of Cortana Analytics really lay the foundation. They lay the groundwork for a lot of that downstream processing. So as a call to action, all of these services, there's information available about both how to use them, how to deploy them, and how to work with them programmatically. All of these services have APIs that will allow you to automate and plug in and to work with them in your tools and your processes. So we've got the documentation centers, both for Data Catalog, Data Factory, and Stream Analytics. And at gallery.cortanaanalytics.com, let me actually jump back into the browser to look at this guy. There is a vehicle telemetry analytics solution template. So if you're interested in looking deeper than this video has allowed us to look at the different pieces that make up this end-to-end solution, you can, with a single click, deploy this into your own Azure subscription to have all of the working pieces, both Stream Analytics, Data Factory. Data Catalog is not yet included as of the time of recording, but there are Power BI dashboards and a Power BI desktop designer file, and there is a literally one-click process that will allow you to get all of those components deployed and ready for you to work with. So you can try the solution end-to-end at the Cortana Analytics Gallery, and make sure that you fill out an evaluation, check out the other videos for build, and thank you very much for your time.